You ever see a huge lightning storm like this and then later get that little zap from a doorknob? They feel like they're from completely different worlds, right? But what if I told you they're basically the same thing, just on a massively different scale? Both are powered by the exact same invisible force.
Welcome to The Explainer. Today we're diving deep into that invisible force, static electricity. We're going to break down what it is, exactly how it works, and trust me, how it shows up in some pretty surprising places in our world. Okay, to really get static electricity, we have to start small. I mean, really small. We're talking about the fundamental building blocks of pretty much everything in the universe, atoms. So here's the deal. Everything is made of atoms. And inside every single atom, you've got these particles with a property called electric charge. You've got positive protons sitting in the middle and these tiny negative electrons zipping around the outside. In a normal, happy atom, those charges are perfectly balanced out. But, and this is the key, those little electrons can sometimes jump ship. If an object loses some electrons, it's left with more positive protons, so we say it becomes positively charged. And if it gains extra electrons, well, now it's negatively charged. That imbalance, that is what we call electric charge. It's the secret sauce behind everything we're talking about today. Now, if you only remember one thing from this whole explainer, make it this sentence right here. This is the golden rule. Every single thing, from your hair standing on end to a bolt of lightning, boils down to this one simple idea. And you can see it in action right here. Two charges that are the same, like two positives, are always trying to push each other away. They repel. But put two different charges near each other, and they pull together. They attract. It's that simple.
So if it's all about electrons moving around, how does that actually happen in the real world? How do things get charged up in the first place? Well, let's look at a couple of the main ways.
The most common way is just good old-fashioned friction. You've totally done this before, right? You rub a balloon on your hair. That rubbing action literally scrapes electrons off your hair and onto the balloon, so your hair ends up with a positive charge and the balloon gets a negative one.
So let me ask you this. What if you wanted to charge something without actually touching it? Sounds kind of like a superpower, doesn't it? But it's not magic. It's just physics.
This whole process is called charging by induction. Let's walk through it. First, you bring a charged rod close to a neutral sphere. Because unlike subtract, all the electrons in the sphere rush over to get closer to the rod. Then, and this is the clever part, you connect the sphere to the ground. The ground is like a giant reservoir of electrons, and they flow up into the sphere. You snip that connection, trapping all those new electrons, and then you pull the rod away. And just like that, the sphere's left with a negative charge, and the rod never even touched it.
Okay, so charged things can push and pull each other from a distance. But how? How do they feel each other through empty space? The answer is that they create this invisible region of influence all around them. It's called an electric field. Any charged object generates one. Think of it like a spider's web stretching out into space. If you drop another charge anywhere onto that web, it's going to feel a force, either a push or a pull. To help us see these fields, we draw these things called field lines. And the rule is, the arrows always show which way a positive charge would get pushed. So it makes sense, right? The lines point away from a positive charge, and they point right towards a negative charge. And this is where it gets really cool. You can actually see what happens when fields interact. Look at the one on the left. The lines literally connect the positive and negative charges, showing that path of attraction. But on the right, between two positive charges, the lines bend away, perfectly showing that repulsion. Now, these patterns follow a few simple rules. The lines always point from positive to negative. They can never, ever cross each other. And here's the big one. The closer together the lines are, the stronger the force is in that spot. Okay, enough with the theory. Let's talk about the real world. Because this force, static electricity, can be incredibly dangerous, but it can also be ridiculously useful. Let's start with the dangerous part. When you're pumping fuel, all that liquid sloshing through the pipe creates a ton of friction. That can build up a massive static charge on a tanker truck. And if that charge creates even a tiny spark, boom, you could have a huge explosion.
Luckily, the solution is super simple but absolutely vital. It's called grounding or earthing. You just connect a metal strap from the truck to the ground. The earth is so big it can absorb all that excess charge without any problem, giving it a safe path to flow away and preventing any dangerous sparks.
So grounding is how we safely get rid of charge we don't want. But what if we could use that rule, unlike subtract, to our advantage? Well, that's exactly what we do with things like spray painting. We can even use static electricity to help clean the air. It's brilliant, actually. Inside factory smokestacks, these things called electrostatic precipitators give all the little smoke and soot particles a negative charge. Then, as the smoke passes by plates with a positive charge, the soot gets pulled right out of the air, just like a magnet.
And this same idea makes painting cars way more efficient. The spray gun gives the tiny paint droplets a positive charge. The car body itself is grounded, making it attractive to those charged droplets. This means the paint literally wraps itself around the car's surface, giving you a perfect, even coat with a lot less wasted paint.
So when you really think about it, it's kind of mind-blowing. From a tiny shock on a doorknob to a massive bolt of lightning, and from preventing explosions to cleaning our air, it all comes back to that one single golden rule. Likes repel and unlikes attract.
So there you have it. Static electricity. It really makes you think. We're already using this invisible force to do some pretty amazing things. Now that you know how it works, what problem are you going to solve with it?